So today we learn how to name and draw alcohols. So what is an alcohol? Well, an alcohol is an organic compound containing one or more hydroxyl group. Hydroxyl should hopefully remind you of the hydroxide ion with that kind of hydrox start to it. And what hydroxyl is it's an O connected to an H, and then that O is connected to a carbon. Okay, so that is what a hydroxyl group is that OH group that then is connected to a carbon in an organic compound. So if it has a hydroxyl group, then it is essentially an alcohol. So how do we name alcohols? Well, it's kind of like naming the rest of this stuff. We just have to have an OL ending, and we need to specify where that hydroxyl group is located, which carbon it is. Now, when we take a look at these alcohols, we want the hydroxyl group to receive the smallest number possible in the parent chain. This takes branches or priority, over branches. So it's more important in terms of numbering than a branches or a halogen group is. It is essentially like our priority for numbering. And then from there, we name branch positions and sizes of branches the same as we did in normal alkanes. If we have multiple bond positions, we place that number immediately after the number of carbons in the parent chain and before the OL suffix. If there's more than one hydroxyl group, then we can do diol or triol or whatever we need to show how many hydroxyl groups we have. So really similar to the work we've done before. So here I have 3 different examples, really simple alcohols for me to name here as examples. So here, of course, I have 1 and 2 carbons. Now, the only place a hydroxyl can be is on carbon number 1. Because if I had it over here instead, of course, that would be the first carbon. So this is ethanol. And this is the type of alcohol you would find in alcoholic beverages. If you named it ethan-1-ol, is that okay? Yeah, sure. You could put the 1 in there and that would be totally fine. For this one, I've got 1, 2, 3 carbons, and this is on carbon number 2 for the hydroxyl group. So this would be propan-2-ol, which is rubbing alcohol. Propan-2-ol is the name for this compound. Well, this one right here, I have my hydroxyl group on 1, 2, 3, the second carbon, and then I also have a methyl group. So this would be 2-methyl propan 2-ol. Okay, so that's 3 different alcohol examples. Now, this is actually to show the difference between a primary, a secondary, and a tertiary alcohol. If you take a look at the carbon that the hydroxyl group is attached to, so here's the carbon that the hydroxyl group is attached to. The amount of carbons that are attached to that carbon determines if this is a primary, a secondary, or tertiary alcohol. So for example, this carbon here has 1 carbon attached to it. So this is a primary alcohol because there's only 1 carbon attached to the hydroxyl carbon. Here I have 2 carbons attached to the hydroxyl carbon. So this is a secondary alcohol. And then finally, I have a tertiary alcohol because I have on the hydroxyl carbon 1, 2, 3 carbons attached. So tertiary alcohol. So 3 kind of classes of alcohols. Why do we care? Because primary, secondary, tertiary, these react by different mechanisms you're not going to learn about in Chem 30, but in the future you'll kind of make that distinguishing thing with different alcohols because they do react differently. So primary, 1 carbon attached, secondary, 2 carbons attached to the hydroxyl carbon, and tertiary has 3 carbons attached to that hydroxyl carbon. Okay, again, we're a little bit late on examples, so let's go a little bit crazy and just draw something a little bit more intense for this. So if I went ahead and drew something like, I'm going to draw a bunch of carbons first. And let's actually attach, just for kicks, 2 hydroxyl groups. That could be kind of neat on that. Let's put a double bond in here as well. So I got a CH2, I got a CH right here, I've got a CH right here because 1, 2, 3 bonds. Here's a CH2, and then here's a CH3. Okay, so the question would be, well, what do we name this particular compound? Well, if I went through, I would start with 1, 2, 3, 4, 5 for numbering, which is better than left to right, because then I reach the hydroxyl on carbon number 3. This way I reach the hydroxyl on carbon number 2. Also good because my double bond is on 1 and 2. So I end up with then, I have no branches, so I can go straight into the parent chain name. Wow, this is a pent 1-ene. Forgot my dash there. And then I have 2, 3 diol, because I have 2 of these actual hydroxyl groups here. So pent 1-ene 2, 3 diol would be the proper name for that one. All right, well, give it a go and then take a look at the key and see how you're doing on this through the work that follows.